Today we're going to take a look at section 1.8, which talks about representing functions as graphs. The first thing that we're going to do is we're going to look at a graph and we're going to tell if it is a function or not. So we've looked at telling if something was a function by listing ordered pairs, we've looked at it by mappings, now we're going to take a look at it by looking at some graphs. So we can tell if something is a function if it passes the pencil test or the vertical line test. We call this pencil test because if you hold your pencil going up and down, if it hits more than one point on the graph, it's not a function. So let's take a look at a few examples of this. So let's rough sketch out a graph here. So we have our graph. We're going to put some points on our graph. So let's see, so maybe we have a point here, we have a point here, we have a point here, we have a point here. If you notice, if I hold my pencil going up and down, I hit one point here, I only hit one point here, I hit one point here. You don't have to draw on those dots, I'm just drawing them in so you can see if my pencil was going up and down where it would be. So because it only hits one point at a time, this is a function. Okay, let's take a look at another one. So if I have something like this, we have a graph, we're going to draw in something graphed on that graph. So if I have something like this, and again I hold my pencil up and down, if you notice, oh, I've hit 2 points. I have hit right here and right here in the same vertical line. So this one right here is not a function. Okay, let's take a look at a couple more. So if I have something like this, we're going to graph, and maybe my graph looks something like this. Again, if I have my pencil and I draw lines going up and down, it only hits one point at a time, so this one is a function. And let's do one last one, we'll squeeze it in over here. My last one over here, if I have something that looks like this. Again, if I draw a line right here, you notice I've hit 3 points already. So it is not a function. All right, we're going to go ahead and we're going to take a look at one that's going to be a little bit different. This time we're going to have to graph the function. They tell us what values they want us to plug in as the domain. We're going to make a table, and then we're going to go ahead and we're going to graph it, and we're going to see if it's a function by what we get when we plug it in. So I'm going to go ahead and I'm going to fill in our table. As we know, we're going to be plugging in 0, 2, 4, 6, and 8. So again, if it helps you to show your work off to the side, go ahead and do that. So this is like saying I have 1/2 times 0. Anything times 0 is 0. If I have 1/2 times 2, remember, it's like saying I have 2 over 1, if that helps you, so then I can cancel out my 2's, so I'm just going to be left with 1, or half of 2 is 1. We can do half of 4, which is 2, half of 6 is 3, and half of 8, which is 4. So now we're going to go ahead and we're going to graph these. We're going to think of these like being ordered pairs. Remember when you graph ordered pairs, you go side to side first and then up and down. So I'm going to graph the ordered pair 0, 0. I'm going to graph the ordered pair. I'm going to go over 2 and up 1. I'm going to go over 4 and up 2. I'm going to go over 6 and up 3. And then I'm going to go over 8 and up 4. So now looking at this, is this a function? Does it pass the pencil test or the vertical line test? And if you said yes, then you're right. So this is a function. The last thing that's in here is going to be a little bit tricky, but it's going to give you a graph, and what it's going to want you to do is write a function rule and identify the domain and range. Again, make sure that you're reading directions, because it's going to ask you to identify these domain and range, and on your test, you don't want to miss that. So we're going to go ahead and we're going to take a look. I'm going to identify the domain. Remember, the domain are all the x values. So I want all the x values of these plots, these points that are plotted. So if you're looking, I have my x. I have an x at 0, I have one at 1, 2, and 3. So that's my domain. I'm going to go ahead and I'm going to find my range. And so my range, if you notice, are my y values. So my smallest y value, we have 2, 3, 4, and 5. Okay? Now I want to go ahead and I want to look at this and I want to say, okay, what's my function rule? What am I doing to the x's to get these values for y? So let's see, it looks like my line is decreasing, which means I know that I'm going to be subtracting or dividing in some way. If x is 0, then y is 5. If x is 1, then y is 4. So my function rule for this one is going to be y equals 5 minus x. And we could check that. So 5 minus 0 is 5. 5 minus 1 is 4. 5 minus 2 is 3. 5 minus 3 is 2. And those are the x and y values that we are getting. Let's take a look at one last one. So again, I want to do the same thing. I want to identify the domain and the range. So I'm going to identify the domain, and I want it to be my x values. So we have 1, 2, and 3 as our domain. Our range here are our y values, which is 10, 15, and 20. When we're looking at them like this, it's kind of a little bit easier. Even though this is probably the most difficult problem, and I probably wouldn't give you one like this on a test. But it's kind of easier to see, okay, I'm comparing 1 to 10, 2 to 15, and so on. So I'm going to look at this, and I'm going to say, well, it kind of looks like I'm multiplying by 5s because it's going up by 5s. It's going up by 5, so I'm going to say that I'm multiplying by 5. However, 1 times 5 is not 5, or 1 times 5 is not 10, it is 5. So how do I get from 5 to 10? I add 5. Let's see if that works for 2. 2 times 5 is 10, plus 5 is 15. 3 times 5 is 15, plus 5 is 20. Yes, so my equation is y equals 5x plus 5.